In this lesson, we're going to learn how to solve systems by graphing. All right, first of all, let's talk about what is a system of equation. Well, a system of equations is a solution to two or more equations. And then what is the solution to a system of equations? Well, the solution ends up being an ordered pair. It's an x and a y. All right, so example number one, how do I determine if an ordered pair is a solution? Remember we just said that the solution is an ordered pair. It is a solution to both equations, or it could be two or more equations actually. And so we have this ordered pair. Our ordered pair is a 3, 3, meaning our x is going to be a 3 and our y is going to be a 3. Now, in order to know if it's going to be a solution, we're going to plug it in. And we're not only going to just plug it into one of these equations, and we've been doing that for a long time, just plugging in an ordered pair to see, well, does it work? But then after we're done plugging it into one equation, we're going to plug it into the second equation. So let's take our ordered pair, 3, 3. And so if x is 3 plus 2 times 3, that's why we're looking at this right here. And then is that equal to 9? Well, 3 plus 2 times 3 is 6. Well, is 6 plus 3 equal to 9? Well, yes, 9 is equal to 9. So we know that 3, 3 is a solution to this first set, or this first equation that we were given. But now we need to see, is it a solution to our second equation that we're given right here? So we're simply going to plug it into that equation as well. So we would have our, let's just kind of make a little line here. All right, so we've got our 4, and we're saying that x is equal to 3 minus y, which is equal to 3. And is that equal to 15? So 4 times 3 is 12. Minus 3, is that equal to 15? Well, 12 minus 3 is 9. It is not 15. So we have 9 is not equal to 15. And because it did not work for the second equation, then that means that it is not a solution to this system or this pair of equations. So we're going to say no. All right, for question number 2, I would like for you to plug these 2 points in, or this point into these two separate equations. I would like you to plug those in and then simplify and then determine if this is the -2, -5 is a solution. So I'm going to pause the video, and then once you've plugged it in to determine if the -2, -5 is a solution, then resume, and then we can check your work. All right, so once you've plugged in the x and the y, I ended up having -5 is equal to -5 for the first one. And then when I plugged in the points for the second one, I had -5 is equal to -5. And since this point is a solution for both of those equations, then yes, this point is a solution to this system. All right, example number 2, how do I solve the linear systems by graphing? There are 3 different methods, and we're going to explore now, or in this unit, we're going to explore 2 of them. And then later on this year, we're going to explore the third method. Right now, we're going to then explore the first method, which is by graphing. And so remember we said that the system is the solution to 2 or more equations. Well, we've got 2 equations here, and then we also said that the solution is an ordered pair. So what we need to do here is we're going to graph both equations, and that the point at which they intersect is going to be the point that works for both equations. So remember, when we graph an equation in slope-intercept form, we have our slope is equal to 3, or 3 all over 1. Our y-intercept is equal to 1. So we're going to start on the 1. So we're going to go up 3 over 1. Now I'm going to back up, and I'm going to do a -3, -1. That makes a positive. When you're graphing these within Schoology, it automatically draws you a really nice line, and so that you're able to find the points of intersection fairly easy. Where these, you know, notice my line isn't the best, but now we're going to graph our second line. So our second line is y is equal to x minus 3. So we've got the slope that's going to be equal to 1, all over 1, a y-intercept that's equal to negative 3. So now we're going to start on the negative 3, and we're going to do an up 1 over 1 slope. Now, if I continue to go in that positive direction, notice I'm looking for the point at which I'm going to intersect. I'm just going to back up by going down 1, negative 1, down 1, negative 1, down 1, negative. And notice right here that where, after I'm done graphing, the point at which the two lines intersect is the solution to this system. So the solution to the system is an ordered pair where you have negative 2, negative 1, 2, 3, 4, 5. So our ordered pair is negative 2, negative 5. Now, if I went back up top there and I plugged in the negative 2, negative 5 for the x and the y, just like we had the example we did, it is going to work for both of those equations. All right, so let's try that again. So our first equation, we've got a slope that's equal to 1/4 and a y-intercept that's equal to negative 2. So we're going to start on the negative 2, and I'm going to go up 1 over 4. And I'm just going to back down. I'm going to go negative 1, negative 4, just so I make sure that I'm going to make this nice and straight. All right, so that's our first line. Now we need to graph the second line. So we're going to then, our slope here is negative 1. Let's put it as a ratio of rise all over run. Our y-intercept is 3. So let's start again on the 3. And now we're going to go down 1 over 1. And again, I'm going to extend this pattern so that I make sure that it's nice and straight. And I also want to find that point of intersection, and maybe you just saw it there. And again, when you're graphing these on your iPads, it is way easier. It's just going to give you a really nice straight line by just plotting the 2 points. But when we're plotting these by hand, it's a little bit harder here. So now notice the point at which those two lines intersect. That is our solution. Our solution to this is, we're walking over 1, 2, 3, 4, negative 1. So I walked to the negative 4, went down 1. So the solution is it's positive 4. Positive 4, negative 1 is the solution to both of these equations, because that is the point at which they intersect. And if I plug that point in to both of those equations up top, you're going to find that it works. So number 3, notice our first one is solve for y, and our slope is equal to negative 1 all over 2, and our y-intercept then is a number without the variable, it's 2. So now I'd like you to plot the 2, and from there we're going to go down 1 over 2. And again, I'm going to just extend out my pattern, and I'm going to extend it going this way too, just so I can easily then see the point at which it intersects. All right, well now notice we've got this this one that what we call a standard form. We need to solve for y here. So we're going to start by minusing 2x all right, so now we want to isolate that y, so we're going to divide by negative 2. And you're going to have y is equal to, all right, negative 10 divided by negative 2 is positive 5. Negative 2 divided by negative 2 is a positive 1x. All right, so slope is equal to 1 all over 1. Y-intercept then is equal to 5. All right, let's plot the 5. We're going to walk up 1, 2, 3, 4, 5, and we're going up 1 over 1. Now, let's then also back up. Let's go down 1, down 1, down 1, down 1, down 1. There we go. now we can easily see the point at which these two lines intersect. Right there. All right, so now all we need to do is identify that point. So we're going to then walk to the -2, walk into the -2, go up 3. So the point at which they intersect is -2, +3. That point right there is the solution to this system. All right, so for question number 4, I would like for you to pause the video. I would like for you to graph both of these lines and then identify the point at which they intersect, which is the solution. And then when you're done, resume the video and we can check your answer. All right, so after graphing, now you did have to extend that second line down quite a bit, going backwards to find that point of intersection. But the point of intersection there is at -3, -4, so that is the solution to this system. All right, question number 5. Let's go ahead and we're going to graph the two of these lines. Again, I've got the slope that's equal to 3. I've got the y-intercept that's equal to 2. So let's start with that one. We're going to start on the 2 and go up 3 over 1. Let's extend down one more. Down 3 over 1, and maybe I'll do it again. All right, so there's our first line, not the straightest, but now we've got a slope that's equal to 3 and a y-intercept that's equal to -4. I don't know, is anybody noticing something about this? Anybody noticing that we have the same slopes? We have a 3 and we have a 3. Now let's think about what do we know about when we have the same slopes. Remember what kind of a line that makes. So we're going to go down to the -4. We're going to go up 3 over 1. All right, well, I'm hoping that some people have thought about what kind of a line that's making. Well, they have the same slope, and hopefully that we're noticing that these two lines are parallel. Well, because the solution of a system is the point at which they intersect, if they're going to go on and on forever without ever touching or coming together, then there will never be a solution. There is never going to be a number or an ordered pair that would work for one equation that would work for the other one. So that is called no solution. And of course, when we put this into our Schoology, it will be then called DNE. All right, so for question number 6, because this video is getting to be too long and then it won't let me post it, I solved for y here for you. So let's go ahead and let's graph our first equation, and which we have a slope is equal to 1/2 and a y-intercept that's equal to 2. So we're going to start on the 2, and we're going up 1 over 2. All right, so now we've graphed this one. Now for our second line then, notice we have a slope that's equal to 1/2 and a y-intercept that is equal to 2. And I don't know if anybody's noticing, but you have the same slope and the same y-intercept because they're the same equation. And so if that happens, what we call this is, because if I went to go graph this, I go, all right, I'd start on the 2 and I go up 1 over 2, up 1 over 2, and I would have the same line. If that happens, it is what's called infinitely many. And of course, how we end up submitting that is by using the infinitely many symbol, because every point that is on one line, it is going to be for the other. So the solutions are infinitely many solutions. So in this lesson, we took a look at how to solve linear systems by graphing.